Welcome to Subatomic Tanvi.
Hi, everyone.
Today we're going to be talking about quantum tunnels.
I think you mean quantum tunneling.
Oh, I thought we could just quantize a tunnel. So, what is quantum tunneling?
So, quantum tunneling is the phenomenon when either an atom or a subatomic particle tunnels through or goes through matter, even though it doesn't have enough energy to go through matter.
That's interesting. So, why does it happen though?
So, it happens because of the weird things that happen in the subatomic world, but one of the main reasons for this is wave particle duality.
So, waves can tunnel. So that's so much more interesting. How do they tunnel? Do they poke holes or something?
No, they do not poke holes or something. Basically what they do is let me pull up a small presentation to explain that. All right, so here it is, quantum tunneling. So in wave particle duality, the particle exists both as a wave and a particle. That we already know. So in this quantum tunneling, we are the particle is being represented as a wave. So a particle's location is shown by its wave function, which is represented by the Greek letter psi, which is over here too, which is a probability wave. So a wave of probability, a wave of chance. So here we have the particle, here we have the wave function. So next, when the probability wave hits the energy barrier, here we have the probability wave, the same one, and then the energy barrier, this turquoise sliver right here, it doesn't stop. It stops some of them, but some particles manage to leak through the barrier and create this faded probability wave on the other side. So, an energy barrier, which is again this thingy over here, is a wall that blocks subatomic particles, although some of them still manage to leak to the other side, which is why this faded probability wave is here. It still exists here, it's just faded. And lastly, if the energy barrier was thin enough, only if it was thin enough, then the faded probability wave over here still exists on the other side. So this may or may not exist on the other side still. So the thicker the energy barrier, the less particles leak. The thinner the energy barrier, the more particles leak because it's allowing more particles to leak through the barrier. So again, in wave particle duality, the particle can act both as a wave and a particle, and it does. But in this, we're thinking of the particle as a wave. So this wave nature allows the particle to skip over the rules of the classical world and of classical physics, completely ignoring them, and just show up faded, but still showing up on the other side of the energy barrier. So that's basically it for that.
Wow. Now I want to be a particle and tunnel my way through all the walls around me. So we've spoken about quantum tunneling, but who discovered this in the first place?
So the fundamental concept and was discovered by multiple scientists actually, some of which include Ronald Gurney and Edward Condon, and also a few more scientists. So these scientists were building off of Erwin Schrodinger's wave equation, so he played like a fundamental role in this too, even though his wave equation was before the time when these scientists discovered quantum tunneling.
And what year was this again? Like 2025?
1928.
Yeah, that seems about right. So, you've spoken a lot about quantum tunneling. Why should we know about quantum tunneling? Why is this even important?
So we all know that the sun and stars in our universe are like big things, like they play big roles, especially the sun. So If it weren't for quantum tunneling, then the sun and other stars in our universe wouldn't work. If it weren't for quantum tunneling, flash memory in our flash drives won't work. And also, if you remember the concept of tunnel diodes, the tunnel in tunnel diodes actually represents quantum tunneling.
Tunnel diodes. Yeah, I remember learning that in college. Um, it seems quantum tunneling has a major role to play in our universe and our generation.
Just like quantum physics in our lives.
Absolutely. Thanks for another awesome episode, Subatomic Tanvi.
You're welcome. Bye, everyone.